Hello, I'm Ivan Yolkin. I work in Kiev and I'm in charge of the safe software solutions. I'm a developer and I participate in the development of the vulnerabilities analysis. I should say that Justin Bieber is forever, and I should explain what happened in Kiev a couple of years ago. We had a life cycle where the developers were doing something, they were testing something. Something was tested, something was not, but ultimately it was all about production. But no one really took care about safety, so ultimately those guys arrived and they say, let's make everything safe. So they did. They entered into a life cycle of those applications and they said that they would be testing as many releases as possible and try to check out what's going to happen. So they had standard measures. They had to do the pin tests of those releases. They checked the code, the applications, but as far as you can see, it was a vicious practice because it does not cover all the applications. We do spend too much time on this testing, and the business is not going to wait for security. And some of the vulnerabilities that were found at the perimeter were becoming known at the time when we were releasing the bug. It was really like fire extinguishing. Strange bugs would pop up, and it turned out that we have such an application. So we had to do something about it. We had a scope, we had 30 projects, we had a certain number of programming languages, tons of developers that can do it, and we need to make it safe, and we just need to keep the business flow intact, and we have just a couple of people in security. So what do we do to protect the internet? And we figured out about this one nice thing designed by Microsoft from DNC, and a lot of you may see this follow when you have a release cycle split into chunks. First of all, we teach our programmers to create a safe code, and initially you need to take care about safety. Then we create a safe and secure code, and there are plenty of flows like that. And all in all, we figured out some of the parts in this C, and we really wanted to automate the parts we wanted to automate. So ultimately, we ended up having such a flow. We had the first part, the ISEC part. We initially check it out and see whether it's safe enough. Maybe there was something wrong about the pins and the passwords. The next step is safe development and regress testing and safe releases. We need to monitor the idea, and if necessary, if it's an implementation of some function in the system, we test it immediately or do it manually. Then we can do everything safely. They write a code, they test the code, by auto tests. We apply our own auto tests there. We check this code for safety, and one of the main cycles there is that before we release a new function, before we start a new release, we automatically verify this code with static analyzers. We automatically phase this new application. We manually do the tests again, and in the end we issue the release and see whether this release is going to have a very good feedback, whether we're going to have pretty good hacker exposure. It's a nice release cycle anyway. The main question, what would this blue tick denote? That's what I wanted to explain. That's how we embedded the static code analyzer into this cycle. The static code analyzer is a thing which starts with your source files, and it looks for unsafe files and bad practices through which some kind of a malicious injection may occur, a stack trace rather. So the whole point here is that it takes the source files and checks whether they're good or bad. It checks the code for safety, and it also carries a number of useful things. The bad coding practice, the search for logical errors, the search for syntax errors. But it's not a perfect solution. Like any security tool, it requires fine-tuning. So we started doing it. And we wanted to start this security tool in a way so it works with the auto hooks, automatically applying it to the new releases. The major aspect of the static code analyzer is that it should be granted all the code, all the clean code, without any artifacts, bytecodes, dependencies. If you have a Java-based application, if this app requires to pull up different libraries with possible vulnerabilities, you attach the source files of the libraries, implement the dependencies. If you use the CDM, you also need to take care about all of the source files, using them in the code. To make sure it works, we created a standalone application which interacts between the team city and sends the code to the static analyzer for analysis. It was a separate standalone application which compiles the source files, injects the code, does the dependency injections, using the custom flow of the languages. For example, when you need to scan and find out how it's going to turn from C code to JavaScript code. So he's looking for some non-conventional features, and it's quite right. We need to use clean code. So all of the cycle of how the code is pulled up is that the developer has written something, has sent a hook to Team City. Please check and verify this code. Team City sends the request to the control center. The control server does a number of manipulations, compiles the files, injects the dependencies. And we do this search. A static analyzer. How did we single it out? We wanted to have a complete flow. So, for example, on a web page, a user inputs data. This data goes to Java code, then to SQL. Then it goes back and it's reflected to access to the client. We expected that, but it did not happen because, as the vendor explained, each part of the code should be separate. It should be synthesized on its own. So, for example, if you send this data from client to Java, in Java you need to track down that nothing can be injected and vice versa. Not all of the expectations may come true. If you're in favor of dependency injection and dynamic code, it will not work straight out of the box because it's a dynamic solution, and the dynamic code cannot be statically analyzed. So the vendor is right here. But we can create our own dependency injection flow. We will be implementing generic classes using implementations of the classes, so it's quite possible. A static code analyzer. The support of the frameworks by one vendor is not possible. This analyzer supports approximately 20 main languages and a bunch of frameworks. If you decided that your static analyzer will work straight out of the box, it will find a number of nice features. It's not true. Each project is unique. If you're waiting for a rule to apply and start a remote code execution, you need to read through a bunch of code, understand that this remote code execution is possible, and it will not be your test classes. So please be prepared to read through tons of code before someone else does it from beyond, because we had some incidents where vulnerabilities were created, RC vulnerabilities. The static analyzer did not find it, but we made it. So in order to start this static analyzer, you need to do your own CDN. You need to write 20,000 strings of code, develop your compilation system, monitoring of the code environment. And to make sure that the code is scanned, you need to create your own rules in the static analyzer. It sounds sad, but despite that there is a lot of it to be done, we actually found approximately 25 bugs, even in XXE, and we still keep on finding them, creating some new rules until now. And we have plenty of products, plenty of projects done just by a couple of people. That's all. I'm done. Thank you.
К сожалению, у нас не так много времени. Я предлагаю там либо вопросы отложить в кулуары, либо один вопрос, может быть, максимум. Вот так.
Окей, встретимся в кулуарах.
Давайте в кулуарах.